Howdy, everybody. Hope you're doing well whenever you are. We're here for Quest 6 for Everybody Codes. I spent the weekend moving back over to Linux, and so I'm back there right now. It may take me a little while to get used to the tiling, but anyway, I think I can solve the problem, and hopefully the recording comes out okay. I tried to move all my OBS stuff over, but we'll see how it goes. Anyway, I don't think I have anything else to say. That the weekend was nice because I got to review a lot of your solutions and your feedback. So also from the subreddit as well. That was really cool. So thanks for all that. And we'll keep trying to do that throughout the rest of the videos. So, let's just get with it, I think. So this one is Mentorship Matrix. C++, C, C sharp. Oh, there's no Rust. Okay, story section. Another morning in the garrison greets everyone with a pleasant chill. The shouts of training knights pierce the air. On the training grounds stands the captain, closely observing his men. As soon as he sees you, he invites you over with a hand gesture. I was just looking for you. This afternoon, the escort to Stack Trace Sanctuary is setting off, so be ready for the journey. Thank you for your invaluable help recently. I hope you find the answer to your questions. Can I get one more favor from you before our paths diverge? Of course, Captain. I'd love to help. Great. Look over there. The captain points to a group of young novices practicing with wooden swords. Their movements are chaotic and uncertain. To become a real knight, they have a long way to go. I have an idea to make their journey easier. Instead of pairing them with one mentor as a squire, the mentor will change from time to time. More mentors means more opportunities to learn. I even have a plan on how to pair novices with mentors over time. You receive a note consisting of a list of uppercase and lowercase letters. Capital letters represent mentors, lowercase letters represent novices. Each letter means a different profession. A is sword fighting, B is archery, C is magic. Any knight who matches the novice's letter and appears earlier in the list can mentor them. The captain explains that this procedure is just a draft method, and first he wants to check only the sword fighting category. For each novice in this profession, A, determine the total number of possible mentors A, and calculate the overall number of possible novice mentor pairs in this category. So we have this long string, and we're only interested in A's right now. So there's a big A, big, little. To analyze this example, let's leave only the letters in the sword fighting category and skip the rest. So we have big, little, little. The first novice A has only one mentor A on the list, who is at earlier position than he is. Each of the two novices at the end of the list has two mentors at the earliest positions. Yeah, so this guy can go to here and here. This guy can go to here, this guy can go to here, and this guy can go to here. Each of the two novices at the end of the list have two mentors, so the total is 5. What is the total number of possible novice mentor pairs in the sword fighting category? Okay, so like what's going through my mind is whenever we get like a big A, well, let's see how big it is first of all. This is small enough that you might be able to, my thinking is go through the list, and whenever you get a big A, increment a count of like how many mentors there are, and when you ever get a little A, count how many were before it. Then we only have to scan it once, right? So you could imagine saying like, for this big A, look for all the little A's, And then for this big A, look for all the little a's after it. But I think, like, imagine we set the count to 1 here, and then right here we know it's 1. And now we set the count to 2, so we know these are 2 and 2. So 1, 2, 2 gives us 4. Does that make sense? I think that's kind of what I'd like to do to solve this problem. So let's try it. I think we just want Vega care. So we'll do input trim cars collect, like that. And then here, do we do a fold? So we do input.iter.fold, and we'll start with 0, 0. So the first one will be our counter, and the second one will be the number of mentors, and the second one will be is our running total. So we'll say mentors total, and then we'll get what our C for our character. And so I think then we just match on C. For this one, let's filter on how do I want to do this? Filter on C A dot contains C, like that. So here we know we'll only get A's. So if we get an A, we want to return mentors +1, and what else? The total, because the total hasn't changed in this case, right? If we get a lowercase a, we want to do total plus mentors. Everything else, panic. Oops. So we want to get the total, which is this. Oh, I need to dereference this a couple times. First time, every time. That did not copy paste. What was it, 137? Yeah. Okay, not too bad. Yeah, so like ask yourself like what do you how do you get there? How do you deduce the solution? Oops. Sorry, I'm still not used to this. A very naive approach is just to say, oh, every time I see an A, I'm going to scan the rest of the list for lowercase a's. And then I know that mentor can handle that many people. And then when I do this, now I know that mentor can handle that many people. But sometimes using like this a sliding tracker works for some of these things. And that's essentially what we're doing is we know that every big A means that all the little A's after are capable of, being a mentor. So you kind of just, if you can keep track of how many mentors there are, then you can like increment, you can figure out how many each of these could be mentored by. So, okay. Yeah, not too tough. Let's see. We do need now to EC input. What was my thing? New 2025 6.2. No, decode. Okay. On to part 2. Man, will I remember my key bindings. Get back into the Linux thing. Okay, let's move on here. The captain seems unsure about his idea, so he asks for a similar analysis of a slightly longer list. This time, however, is providing the total number of Novus Mentor pairs for all categories. So now we're interested in A's, B's, and C's. So this is the same thing, but presumably it's just a much longer list. And I think this is where I would say your naive approach may not work. It's still relatively small, so it may still work, but now we need to track A's, B's, and C's, right? So, how do we want to do it differently than part 2? I mean, we could do it one at a time, would be like the fastest way, where we just filter by A's, B's, and C's. Should we see if we get that right? Or should we try and track them actually in a hash map? So we track it as a hash map, and then we'll say we'll have to make this mute. So if it's an A, how do we want to do this? We want to do mentors.entry. Oh, actually, we do this for all of them, huh? No, we only do if it's capital, we only do the thing. So we do or default plus equals 1. And then we return mentors total. I already know it's gonna, let's see. Oh. Like that. So now we just want to, now we're going to, for B and C, we're going to say we'll return the mentors plus the mentors of A and B and C, I think. Borrow. It doesn't know the type. Can I do it right here? No. Oh, I have to do it right here. FX hash map car usize like that. I have to say this is oh, is this like an issue with folding? I think we have a good solution. We just are dealing with like weird C stuff. Value borrowed after move, considered cloning. Can I do this? Return type of closure is blah. Someone will have to tell me with more Rust, like what would be better. Like, we can do like let mentors equal fx hash map default. And then we just keep the total. So we don't need this then. So we do this and we total. How about that? Oh, there's no one now. No entry for key. Oh, how about that? Okay, well, that's probably right. Should we see? No, it's not correct. It's not correct. Okay, so let's just... Why would that not be correct? This one's 5. This one's 3. 1, 2, 3. So if we get an A, we insert. We return the same total. B, we insert. C, we insert. Otherwise, we do total. How many do we have? Total. How many do we have? Total. How many do we have? And that should give us the... Oh, I'm filtering still. That's probably it, right? If I don't get it right this time, I'll put it in the... I'll try the example case. But I think I just... Obviously, I was only doing the A's. Okay, not too bad. So what's going on? We fold again, but we keep track of these minters. Maybe in the conclusion, we can go back and try and fix this. I presume I could fold a hash map. Maybe instead I use a scan, because then it gives me like this mutable value right here. And then I just do this and sum. Okay, we'll do that next time. But my issue, I think, was I had the logic right. It was just missing the Rust part of it. Even after doing Rust for a couple years, I still feel like sometimes I mess up with the borrow checker. What else? Oh yeah, and then I was still filtering from part 1, so that was copy and paste error on my part. So okay, part 3, decode 3, and try again. Part 3. Together with the captain, you agree this assignment method is impractical. It'll be far more effective to pair novices with mentors based on the distance between their tents. The final list contains all mentors and novices currently stationed in the garrison, and its order reflects the actual layout of the tents. However, you've noticed this layout follows a repeating pattern, so you've recorded only a unique segment. The segment should repeat 1,000 times. Okay, so we get a small segment, but it repeats 1,000 times. Okay, to represent the full arrangement. Okay, you propose a method which allows the novices to switch mentors without wasting time on relocation. To achieve this, the novice can only be mentored by knights who are on the list no further than 1,000 tents to the left or right of the novice. Example, based on this, okay, so they're only going to do it 10 times instead of 1,000. Well, the distance is 10 and it repeats once instead of 1,000. Okay. All of the mentors M who are close enough to novice N have been marked below. For even better readability, the range limit of the current novice being verified is marked with dots. Okay, so like this novice, did it say either directions? Left or right? How big is the segment? Where do I want to do that? $10,000. Okay. The segment should be repeated. However, you notice that the layout follows a repeating pattern, so you record a unique segment. Segment should be repeated 1,000 times to represent the full arrangement. You propose a method which allows the novices to switch mentors without wasting time on relocation. The novice can only be mentored by knights who are on the list no further than 1,000 tents to the left or right of the novice. I don't think it says anything about wrapping, right? Yeah, because if you could wrap it, go this. So it is a bit weird that you do it 1,000 times, but it's like small enough that I still feel like you could just put it in memory, if that makes sense. And then I think what you want to do is looks like a sliding window. Sorry, I was just thinking about it in my mind. This looks like what's called a sliding window problem. So we can figure out, like, I think we can just duplicate it all. But what I would imagine is once we figure out like how to represent the like, here's my sliding window, like that's what we're really interested in, is like, what's my sliding window? And the way sliding windows work is you basically take a chunk of an array, like a beginning and end, and you kind of prep the prep like a tracker that contains information, and you slowly increment either the beginning or end or both. In this case, it's going to be both. And you just keep doing that until you come upon these values. And then within the thing, you say, what values do I have there, if that makes sense, right? What values do I have inside that array? I hope that makes sense. The idea is for this A, it says we're only 10. So we have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side, and 1, 2, 3, 4, 6, 7, 8, 9, 10. So the whole window is this. And we're gonna do that middle value, right? And we're gonna say, okay, oh, it's A's. I already have filled a hash map with all of these values, so I'm gonna look and see how many A's I have. And then when we move over, what happens is we shift the whole thing over like this, and now it's a B. So we say to ourselves, how many B's do we have in our hash map? And every time we move, we're going to add a value on this side and remove a value from this side in our hash map, our counter of mentors, if that makes sense. So I think that's what it's asking you to do. It's just saying, hey, create this segment 1,000 times. I was correct in that the input wasn't too large, right? It's 10,000 plus another, so like 10 million bytes. I mean, it is a lot. It's going to be like 10 megs. Do we just create 1,000 things, or can we figure out? So the question is like, can we figure out where we are? We probably can. Did I already do an input decode for part 3? Yeah, we did. Okay. Okay, we could probably figure out what we're adding and what we're removing. So let's just get coding and try it, and hopefully it'll make sense what happens. So we're gonna have an input, and we need to figure out. So we know we're gonna have 1,000 to the left and 1,000 to the right, and then we're gonna start in the middle. Well, actually, we're gonna start at the beginning, and we're only gonna have 1,000, right? If you think about the input, like this first C will go here, but it'll have all of these. So our left side won't grow until we have 2001 in our window, and then we'll slide the window over. So we'll have to take that into account. So it will be, so we'll say our start equal actually, I think they usually do, we usually do left and right. So like we do let mute left equals 0, let mute right equal 1,000. No, what was it? 1,000 times instead of this is only no further than 1,000 left or right. So that's correct. We start right here at 1,000. So now we need to build our initial hash map. So we'll do let mentors equal Oh, I can't do. We've done this before, right? There is a counts thing. It's still only ABC, right? Yeah, so we'll do ABC. C. Oh, I actually think it's going to be like this. It returns a regular hash map. So we'll do that. So now we have like our initial count of what's in the first 1,000. Oh, we actually want to do input iter take 1001, right? Because why do I say that? We're on the right. We're on the let me cur equals 0. So where are we at is the 0th position. Okay. This is going to have to be mutable too. But now we're just going to say like I'm trying to think of like this segment should repeat 1,000 times to represent a full arrangement of tints. So I guess it would be cur in, so we don't actually have to track cur. So for cur in 0 ... and it's going to be 1,000 times input dot len. So at this position, we now want to say how many minters do we have in our minters list. So we'll say let total mute total equals 0, and we'll call this total. So we'll say total plus equals match input cur mod. I'll find it mod input dot len. So that's going to give us the character, and if it's an A, we want to do total plus equal mentors ampersand A. We want to do this for B and C. Otherwise, we'll return 0. Oh, wait. No. Okay. So we update our total. And now we shift the sliding window. So what does this entail? The right will always shift until it is at the end. So we'll say if right less than 1000 times input dot lane, then we can shift right. We say right plus equals 1. And now we want to add that character to the mentors. So we do mentors dot entry input right amper input dot lane. One. I'm gonna have to do this, I think. Have an extra one of those. So if we haven't reached the end, we're okay to not shift it. Is there going to be a -1 issue here? This one actually is 1000 because the position here is 0, right? So think about the values here. Like this position is 0, and it should go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to right here. So it is 1000. Man, I'm alt tabbing all over the place. So I say if right is less than this, because if we ever get to this point, we've gone too far, right? It is -1. We'll do it one last time and then we won't want to do it. What does this say? Can't be dereferenced. Why can you not be dereferenced? Expected car found car. Oh, I know what it is. We do or default. There we go. So that is not the right answer because we aren't sliding the left yet. So when do we slide the left? We'll say if we start sliding when cur equals 1000. If cur greater than or equal to 1000. Left plus equals 1. And then we want to remove that value. This should always be here, but I think we have to keep it like that. So is that right? I just want to double check these to make sure I'm not off by 1. I realize it's taking a little bit longer, but we take the first 1001 because we're going to start at 0. We're going to start at the first one, so we want to have 1001 of them in our thing. And then we're going to go through all the values 1000 times the input lane. we're going to check and see how many mentors there are. A, B, C. And then we want to shift our sliding window. And the question is, when exactly do we shift? We stop shifting the right if we ever get past 1,000 times input lane minus 1. And you'll always shift the left when cur is greater than or equal to 1,000. Is that right? Like if it were 10, man, Alt Tab is going to kill me. If it were 10, so this one's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when it's 10, I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so when it's 10, 2, 3, 4, 6, 7, 8, 9, 10. No, it's only when it's greater than. Interesting. Because right here there's 10 in front of it. So if this would be our starting, if I was right at this position, I wouldn't increment left until I got here. So it is greater. So it's not greater than equal, I think. So I kind of feel like I want to test this. They probably give us a better example. For the same example, if we repeat 2 times with a distance of 10, for the same example, if we do 1,000, 1,000. So this is we want to do this one. Oops. My key bindings, bros. I kind of want to test this. Just see how good we got. First, I should learn to type. That doesn't look like 344, 232, 1. Not even close. 1,000, 1,000. Am I doing? The question is like, what number is off? Like, I can just start doing things. That changes it a little bit. Oh. I want to remove and then shift. I think that's right. I do want to remove and then shift. Still no bueno. I do feel like I have the logic close, so there must be some bug in what I'm thinking. If we repeat the pattern 1,000 times, and use the distance limit of 1,000. So 0 to 1,000. Our left is at 0, our right is at 1,000. Am I right? We want to take 1,001. I think so. Oh, there's not 1,001 in the list. Cycle. Isn't there a way to cycle? Yeah. Okay, I think that's my bug in the testing. Oh, we're much closer. 3, 4, 4, 2, 3, 2, 1. 2, 3, 2, 1. So it's these values that are probably off a little bit. Okay, there we go. Do we try the final one? I didn't alt tab that time, boys and girls and all those. Hey, we got it. Okay, good job. Not too shabby. So what is the intuition here, or what is like the thing you need to deduce to get to this point? I think the key factor in part 3 is when it says you have like 1,000 on either side. Like that should signal sliding window. And I apologize if I didn't do a good job of explaining what a sliding window is. But again, at a high level, the way to think about it is you're going to have some window and you're just going to keep moving along that window all the way to the end of the array. And you have to figure out some funny logic. For example, we start at 0, so our left isn't going to move until our window's big enough. I actually think that's the way this happens here, is you do like it's something along the lines of, let me do this so I can make sure my changes don't do it. I think the way they do this when they know the size. So we know the size is going to be 2001. So we say if right minus left is greater than 2000. This doesn't work either because the end follows off. So we might have to just leave it how it is. Sometimes there's a way to say when the right minus left. Someone may help me. Maybe you can help me in the comments, but anyway. But the logic is we're slowly going to slide, and then all we have to do is add or remove our counts as we're sliding, right? So we update our counts here, and then we update our mentors down here. I didn't say that right, huh? The idea of a sliding window is do your counts with your section, with your current section, and then slide the window one. So we're going to update our counts, and then we're going to slide the window one. And the sliding has some special logic here because we don't want to start moving the right, or we want to always move the right until we get to the end, right? We don't want to fall off the end. And we want to start counting the lefts as we get here. Or we don't want to start upgrading, removing the lefts until we get to past 1,000. I think that's greater than or equal to because it's 0 based, right? And so that's why it's equal to. That's where I was off. But the key here is on the right side, you're adding, and on the left side, you're removing. And that's usually how a sliding window works. You just keep doing that. So, okay, conclusion. Today wasn't too bad, right? Let's clean this up a little bit. Remove all unused imports. I added these little trackers over here. I guess you can't see my mouse. To tell me if I get off when I change the code. What did I wanted to see if I could, instead of doing a fold, I could do a scan. So the way scan works is slightly differently in that it outputs a value each time. So in the end, because we're scanning now, we're going to want to sum all of our values. So this one won't panic. Instead, we'll just return 0. And these ones will always just return these. These ones will always return 0. Now our mentors will be here. It'll be something like that. Oh, I need to make this mutable. What does it like? That. Oh, all of these have to be wrapped in sums because why doesn't this have what's wrong with this? Oh, it's assumed mutable. Okay. Okay, so that works a little bit better. So what's the difference there? With a fold, it's going to produce a value and like that value is going to be reused. I think in like other places they call it reduce. Whereas what a scan says is here's some state and it's going to output a value at each of those states. And so, but it's going to give you your state, and then it's going to give you the value in the iterator, and it's saying you need to output a value based on that state. So what we do is we just say, for the uppercase letters, we increment our counters and return 0 because those values don't change our don't change our like final totals. If they're lowercase, we return the values that we have in our mentors list. So now it's going to say, like, if I get a lowercase a, for example, it'll say, oh, there's been 3 mentors before, so I should output the number 3 for that mentor, and then we just sum all those values up, and that will give us our U size. So that feels a little bit cleaner, at least from, if you're doing a fold. One might argue that, if you look at what I'm doing, it's quite possible that a for loop might be faster, which is what we do in part 3, all right? So that does beg the question is, could we update stuff? Oh, it's usually cleaner to put these down here. Like that. And then sometimes people like to do this because it makes things clearer. I don't think in the end it changes the running time much, but in here we can switch. Yeah, it's hard to say if that was. It technically is slightly faster, and so maybe it's just this is a call. I would think maybe the Rust compiler can't unwrap this or like inline it. I don't know why that's consistently slightly better, but okay. Update our total, shift the sliding window. I mean, this is exactly how these things work. Could you turn this into something more functional? I mean, you could do a fold with your mentors. Left, right, cur. But you still have to do a lot of this, like, you're always going to have to do this. Oh, did I talk about that? I don't think, like, if you said, oh, I'm just going to copy this 10 million or 1,000 times and it's 10,000 bytes, like, I think that works out to 10 megabytes. And so most machines can run on 10 megabytes. Well, I do know that there's some people that like to solve these puzzles using like old computers. And so in their cases, they definitely have to do something like this. But again, I think it's just as easy to figure out like where you are in the thing by just, again, we've done this a lot, right? Is you can just say, oh, I'm just going to do the modulus of the thing, of the length of the array. And that puts me somewhere in the array. We did that before when you're going backwards and forwards with Rem Euclid. So, okay. Let's see. Oh, let's check our progress. See what happens to our bird. I'm going to zoom out really quick for this one. And I'll zoom back in. Oh, I got bigger. It's a duck dragon. Actually, ducks have wings. That's awkward of me to say. Those look more like dragon wings, though, so I feel like it's maybe a duck dragon. Let's look at my times. Day 6. This one definitely felt, I mean, look at the last time, right? Yikers. I'm still sick. I'm just checking. I actually went to the doctor because I had a swollen lymph node here. I wanted to get it checked out. 1, 2, 3. Pretty good. 1 was pretty fast. Most of that was reading, right? Part 2, I had a couple bugs. What was that? Copy paste error. I just need to get better at that. Copy paste. I don't want to do the thing, but and then I had to figure out the thing. I should have just said, oh, if I'm going to do this functional, I should use scan as opposed to fold. But if you have a better way of doing the fold with the hash map, that would be interesting. Notably, I actually didn't use the... Excuse me. It doesn't allow me to specify the hash map type. Okay, so here's what it does, right? We've done this before. It uses for each, but I think we've used fold in the past. Should we see how much faster it makes it if we filter ABC? There's only 1,000 of them, so I don't... Well, but if we use so instead of counts, if we do a fold and we do fx hash map default, am I going to run into the same problem I did before? Map. Entry C dot or default plus equals 1. That way does work. Oh, it's substantially faster. That is like 3 times as fast moving to FX hash map. Probably because we're doing this 10 million times. So any incremental gain is pretty huge. Again, if you haven't been following along a lot, this FX hash map uses like a much simpler hasher that's not cryptographically secure. The standard one protects you against denial of service attacks, I think, or something like that. I'll have to go back and remember. But it's very fast. It's just not nearly as fast as this one, because this one is, a very simple hash, I guess is the way to say it. So, okay, I like that. Should we see where we're at then? How other people solved it? Solution spotlight. Got all 3 on my first try. Nice. That is very good. I'm solving it in Python, and for part 3, keep account of 1,000 previous ABCs and ABCs. I mean, I presume you use a counter or something like that. C#. Using my own library, focused on allocation-free code. Span T is everywhere. Today was easier than previous days, not so complicated with the help of some span helpers to get the area searched for P3. Then count only in that area. Should we look at the code? Yeah, okay, it looks like they're actually creating the 10 megabyte thing. I don't think there's anything wrong with this, right? Again, I think it's small enough that for most computers, you can say, oh, I'm just going to, sorry, I should zoom this in. Oh, I'm just going to do the 10,000 or the 10 megabyte character array or whatever, right? And it's not that big of a deal. Eat your heart out, Bill Gates. Did he actually say that? I've heard somewhere that some people have said you'll never need more than... He didn't actually say you'll never need 64K of RAM. Back in my day, I was old enough when he apparently said it. I just wasn't into computers. I was still kind of a toddler. Yeah, and then you just go through the whole thing. If it's an lowercase, area equals input dot try slice distance times 2 plus 1. Okay, so this, if I understand this right, what's happening is like they're building the area up. Is that right? They're like building the array, a slice of the array, and then they're getting counts that match the character at like the middle position. So this is the more like traditional approach. Like if you thought about it, like what would be the simplest way? And I think like the thing that allows you to get a little bit faster is to say, oh, I can do the sliding window and just update those values. The sliding window is a tough one though. Sometimes it's very hard to like figure out how to shift the arrow or how to shift the ends. Like a lot of them are trying to find you'll find problems that you have an array and you're trying to find some global min or global max or some largest sum or something like that. And so what will often happen is like the right will grow and then stop at a point, and then the left will grow and then stop, and then right will grow and then stop and left. So it makes this kind of like accordion style movement through the array. And so sliding windows can be hard to understand. There's some of them that I still have to look up and can't figure out. This one was easy enough to say, oh, we're going to build a static window and slide across. Although I will say too, I kind of got help on part 3 because I had my numbers off and I copied this and pasted it. So those off by one things get me all the time, right? That's always the case. Well, there's only a couple solutions. I did this a little early because I have to go somewhere tonight. Oh, here you go. Right close to where I was, I think, right? Oh no, this is someone different. There's another person like Man-Eating Ape or something that has some cool Rust solutions. Did the first part 2 parts really quickly, third part tripped me up a bit. I think I was the same way. I spent a lot more time reading the problem on part 1 and 2 than solving it, but got there in the end. I do it in 2 passes. First, looking to the left up to range, and then reverse the list and look to the left again to get the rights. As we go, keep a map of Mentor to VecDeck of positions in those. When you find a Novus, prune out any mentors that are too far away now and add the... Oh, that's interesting. You could keep them in a VecDeck and slowly add and remove. Let's see. Again, I think the sliding window is probably the fastest if you understand it. Okay, if I had done something like this, I wouldn't have had the issue of filtering in the second one. Bugger. But yeah, this looks really close to my code, right? You fold, and then you're just interested in the last part. And they're only interested in A's. Anything else, you just pass the other thing. Okay. Yeah, that's good. What is this? Count novices. 1 usize Mac input as bytes. This must be used for part 3. Yeah. What is a vec lookup? Oh, they're just putting A, B, and 0, A, B, and C, and 0, 1, 2, 3. So that is an interesting thing. Is like, in my code, I explicitly use a hash map here, but there's only 3 values. One could argue that you don't even need to use a hash map, and it might speed this up even further. I have a little bit of time. Should we actually try that? I want to keep this stuff. Iter cycle take 1,000, filter ABC cloned. And now we fold it into just like A, B, and C. And then we do match C A. We return A plus 1 B C. So this one is here. This one is here. So now we got A, B, what isn't like there? Could not find A in scope. Huh? Oh, missing a comma there, probably. Like that. So now these are just like Mentors 0, Mentors 1, Mentors 2. And then these have to be matches. I can type. Oh, I actually didn't. What's funny is there's lowercase a's in here as well. That's kind of funny. So this one we want to do mentors equals plus equals 1. Like that. And then we want to do the same thing down here, but with left. And now we're going to do minus. What do it you like? Non-exhaustive patterns. Which one's non-exhaustive? Oh. Yo, it's off. A, B, C. Start at 0. Add A, B, C. Oh, right here. I can see it. Okay. So that's actually faster than using a hash map. So you could argue that's better. I don't know. Is it better? It's not very readable. So you could do something like struct mentors A U size, B U size, C U size. And then you could oops, I'm doing that wrong. It's like this, huh? And then we say mentors. That's weird. My notifications popped up. Mentor 012. So it'd be like mentors dot a plus equals 1 Mentors. Somehow that worked. What was I having problems with before? So A, B, C. A, B, C. Oops. Huh? Huh? Oh. Okay. That doesn't add much time. Okay, there's also a trick.
A simple card trick involves asking someone to pick a card, memorize it, and return it to the deck. As you shuffle...
Man. Thanks, Gemini. So we can put this here, and then we can impl index, mutable index. We had to do both. Someone has showed me how to do this before, and it's kind of cool. So we do the same logic here. We do like match C, and we do self. Something like that, maybe. What doesn't like about this? Do I need to dereference these? I did that wrong, huh? Like that. So now down here, I can actually do no, it's right here. It's total plus equals mentors input cur modeling, like that. Invalid. This should return 0. How about that? Now it's wrong. Oh, RA, RB, RC. There we go. So we're going to be getting lowercase. We're only interested in the lowercase characters. Any other characters, we return a 0. This feels like it's complicating things more. So we'll try it, see how it looks. So now we impl index mute. Index mute. We match on index again. if I just do this? This one's a little tricky because I actually don't... Well, I guess it works. Oh, I haven't used it yet. It's not going to work because I might get invalid characters here. This one I won't. But this one I will. Right? Because I could potentially get lowercase characters that I don't actually want to decrement or increment C from. So I'm actually feeling like maybe I don't want to do it this way. I wonder if you could return some for this. Let's get rid of this thing. I'll go back to my original solution, I guess. This isn't my original either. Oops. Now I don't know where I'm at. Do I really want to re-implement that? Oh, I need to do that. Oh, I have it right here. That looks much cleaner than my second take. So we just need to fix these. It's like mentors.entry. A or default. Gotta do that. Nope. Nope. Yep. What doesn't like about this? Return type of this call is car due to type of argument passed. Oh. Is that what it was? Okay. We're panicking. No entry found for key, line 71. ABC. Oh. Okay, I think we're back to where I was. Sorry, that was a crazy little departure. It did give us time, though, to see if there's more answers. I like looking at the answers of what everyone else did to kind of see where we're at. C# Rust, so that was the one we just read. Java. This runs in 10 seconds. Okay, so definitely slower than my 60. Static long solve. Dist repeats S. String. Okay, yeah, you're just doing a for loop in the thing and counting. Interesting. Yep, runs in. Okay. Yeah, I mean, the thing is like, if you think about it, is like you're checking 10 million, but you are checking a subset of 10 million. But you are doing 2,000. This is actually something I've noticed about Everybody Codes, is some of the solutions are bad enough that they will take you 10, 20, 30, maybe a minute to run, but you can still do it in a very naive way, whereas you can definitely come to an optimal conclusion. Instead of each novus in the input mentors, check within plus or minus 1,000, wrap in out. Part 1, part 2. It does look like you're just checking and incrementing, if I have that right. Okay. Lots of interesting. I definitely think this is one where you could do it either way. Instead, for each novus in the input, check mentors plus or minus 1,000. Wrap the indices that lie outside the input, then deduct a number. Oh, that is an interesting approach. So their solution isn't quite the naive of just create a 10 million, which I think we've seen in previous solutions. It's like, if for each novus in the 1,000, in the 1,000 line string or the 10,000 line string, I can tell what's behind and in front, and I just times that by 1,000. Does that make sense? So that's even faster. probably than my sliding window algorithm. That's a cool idea. Does that make sense what's happening? So in my solution, I go through all 10 million of them and slowly increment my counter. What they're doing instead is they're saying just find each of the places and then pull the mentors out and figure out how many there are. And then based on that, do the counts. I think if you did a combination of both, which I've run out of time, so I would love to see you do it. Send me your solution. Use the sliding window, but expand the window back and then just multiply it by 1,000 as you're going through. And it will probably be faster than both ways. So, because this sliding, the way I've implemented this sliding window, it's doing like the length, it's doing this loop, whatever, 10 million times. But I think this solution, yeah, like you can still see is they still have to loop through the negative 1,000 to plus 1,001 to figure out like how many you want to add to the thing for each of the values. So like if you'd already built up the counts and then updated them as you were sliding through, both of those together might give you an even faster solution. So, okay. I think I'm going to call it here. Today was a lot of fun. Not too tough of a problem. I had a couple bugs I had to work out. I think, though, I understood what I wanted to do in all three problems. So that always feels good. Like in the previous day with the fishbone, I had no idea. And it sounds like, from what I've heard, no one's heard of fishbone before, so it's kind of a new data structure. I don't know if it'd be useful for anything. That might be interesting. But so implementing that and reasoning about it and coming up with it on my own felt kind of like it took a lot of time. Whereas this problem, I kind of understood what I needed to do. It was just implementing that, and that's what took the most time in solving it. And then fixing bugs here or there, right? So, yeah, grats to this person, first try, because man, I always have a bug, and it's because it's silly things, right? Copy and pasting, stuff like that. So anyway, thanks everybody. Appreciate you watching. Again, let me know down in the comments, did you solve it, and post your solutions here on Reddit. I also read these. But let me know, how did you do it differently? What things could I do to improve? What did I mess up? Maybe I got some of my conclusions wrong here. So I'd love to see what you have to say. We'll talk to you next time. Bye, everybody.